Video 2.7 Image Analysis in Azure. In this video, we will cover the following topics: Basics of Image Analysis, the Analyze Image API and all its features, example applications using the Analyze Image API, use cases of image analysis in Azure. The Computer Vision service of Microsoft Azure provides the image analysis service, which can analyze images and return detailed insights about an image and the objects it depicts. With the image analysis service endpoint, your application or client takes an image, calls the API, and gives back detailed information on the various visual features, characteristics, and attributes found in the image. The image analysis clients can also perform various tasks that are related to image processing. The image analysis service has a lot of capabilities, and in order to utilize them, we use the Analyze Image API. Let's look at all the features it provides one by one and also implement them in Python. Tagging the visual features in an image. The API can identify and tag visual features in an image from a set of thousands of recognizable objects, living things, scenery, and actions. Tagging is not limited to just the main subject, but it can identify people in the foreground. The API also includes the setting like indoor or outdoor, furniture, tools, plants, animals, accessories, gadgets, and so on. These tags can be attributed with the image as metadata, which can summarize all the attributes of the image. For example, the tags returned for Burj Khalifa image may include skyscraper, tower, and so on. Detection of objects in an image. Object detection is almost similar to tagging, but the API returns a bounding box for each tag applied. For example, say an image contains a person with his pets. The detect operation will list all the objects in the image and their coordinates. You can use this functionality to further process connections between the objects in an image. It also tells you when there are multiple instances of the same tag in an image. Detection of brands in an image. The API can identify commercial brands in images or videos from a database of thousands of global logos. You can also use this feature to discover popular brands on social media. Categorizing an image. The API can categorize an entire image based on a category taxonomy with parent-child hereditary hierarchies. English is the only supported language to tag and categorize images currently. Describing an image. The API first analyzes an image and evaluates the objects that are detected. It then generates a human-readable phrase that can describe the detected parts in the image. Depending on the contents detected, the service may return multiple results or phrases. Each returned phrase also has an associated confidence score that indicates how confident the algorithm is in the output description. The highest confidence phrases will be listed first. Detection of faces in an image. The API can detect the faces in an image and provide information about each of the faces. Other features it returns are the coordinates, gender, and age for each face. But this is only a subset of the face service functionality. Face service APIs are used for more detailed analysis, such as facial identification and pose detection that cannot be done using Azure's computer vision. Detecting the image types. Image characteristics can be detected and classified if an image is a line drawing or if it is a clipart. Detecting the domain-specific contents in an image. Domain models can be used to detect and identify domain-specific contents in an image like celebrities and landmarks. It also returns the name of the celebrity or landmark if detected in an image. Detecting the color scheme. It returns color usage information within an image. It can determine if an image is black and white or color, and for color images, identify the dominant and accent colors. Generating thumbnails can analyze the contents of an image to generate an appropriate thumbnail for that image. It generates a high-quality thumbnail first and then analyzes the objects within the image to determine the area of interest. Image is cropped then to fit the requirements of the area of interest. The aspect ratio of the generated thumbnail is adjustable depending on your requirement. Region of interest can analyze the contents of an image to return the coordinates of the area of interest. Bounding box coordinates of the region are returned for the app to modify the original image as per its needs, thereby cutting down the process of cropping image and generating thumbnail. Moderate content in images. You can use computer vision to also detect adult content in an image and return the confidence scores for different classifications. The threshold for flagging content can be set on a sliding scale to accommodate your preferences. Let's look at the code now. We have imported all the libraries and packages that we require in this part of the code. Next, make sure to assign the API key an appropriate endpoint API URL that we have seen on the Azure portal page previously. The next step is to authenticate the client. Instantiate a client with your endpoint and the key that you are assigned after creating a Cognitive Services resource group in Azure. Create a Cognitive Services credentials object with your key and use it with the endpoint to create a computer vision client object. Now give the image URL that you are going to use. Let's verify this URL. Let's look at all the features that we have seen till now being implemented using Python. Describing an image. This is where we call the API, and here is where we print the caption from the response with a certain confidence level. Let's run and look at the response. We can see how the API service has described the image. Categorizing an image. Select the visual features to be studied here. This is where we call the API, and we print the results here by using confidence scores. Tagging in an image. This is where we call the API, and we print the results here by using confidence scores. Object detection. I am giving an image here with objects to be detected. Let's verify this URL. This is where we call the API, and we print the results here by using bounding box coordinates around the objects. Brands detection. I am giving a brand logo image here. Let's verify this URL. We are selecting the visual feature brand here. This is where we call the API, and we print the results here. We can see the output. Face detection. Giving the image that we want to be detected here and also selecting the visual feature faces here. Let's verify this URL. This is where we call the API and we print the results here. Let's look at the output. Detect adult or racy content. The earlier image is taken here, and let's see if it is classified as adult or racy content. Select feature adult and call the API. We print the results here. Let's look at the output. Detect the different aspects of color scheme in an image. Select feature color and call the API. Print the results, and this is the output. Detect domain-specific content like celebrities and landmarks. Give the celebrity image URL. Call the API. And let's print the results. Here is the celebrity identified. Give the landmark image URL. Call the API. And let's print the results. Here is the landmark identified. We have reached the final part of the code where the image type is detected and classified if it is a line drawing or a clip art. Give the image URLs. Give the visual features required. Verify the URL and call the API. Let's print the results and now look at the output. We have successfully completed the code on the computer vision service image analysis. use cases of image analysis. These are some of the use cases of image analysis now, though I see a lot of use cases for it in the future. Real-time processing of components in large manufacturing plants to help with fault detection. Analyzing the torrents of social media data to help unveil actionable insights. Help improve the security systems and ID recognition for secure environments, and many more. Keeping these sample use cases aside, I believe some of the biggest benefits of this API can be realized when it's integrated with the other powerful APIs in the cognitive service. For example, by integrating with the Text Analytics API, you could lay an extra layer of intelligence to image tags identified, giving further insights into the image. You might also think of using the Computer Vision API in a Windows service that can automatically process photos, scan in invoices or receipts to help automate the elements of your business or workflows. Video summary. In this video, we have covered the following topics: basics of image analysis, the Analyze Image API and all its features, example applications using the Analyze Image API, use cases of image analysis in Azure. Section summary. In this section, we have covered the following topics: an overview of vision services, basics of Face API, the Azure Face Detection Model, the Azure Face Verification Model, basics of computer vision, optical character recognition in Azure, image analysis in Azure. In the next section, we will cover Azure Speech Services.